Following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For AZPM, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Today we'll talk with Dr. Mohammed Hassan, Associate Professor of Physics. Thanks very much for joining us today.
Thank you for having me.
You're developing instruments that let you see not just at the femtosecond timescale, but actually at the attosecond timescale. What is an attosecond?
The time difference between 1 second to the edge of the universe, which is billions of years, is similar to the time difference between 1 attosecond to 1 second. So you can imagine how extreme fast we are talking about here.
And that's what's necessary in order to detect the motion of electrons.
Right, because the native time scale of electron motion is attosecond time scale. So we need to go that fast to be able to resolve this electron motion.
So tell us about the microscope. Essentially, it's a microscope
Yes.
that you've developed that lets you detect
Yeah.
electrons.
So the development of ultra-fast electron microscope in general started in 2000 by a group in Berlin Technical University, and they used for the first time laser pulses to generate short electron pulses. When you have your own smartphone camera 10 years ago, and you will try to take in a picture of moving object, you always see it blurry. You cannot see the details of this moving object. So the idea always to make the shutter faster. And inside the electron microscope, the shutter is the electron pulses. So we need to create very short electron pulses to increase the speed of the imaging. Then we can reach faster and faster and faster imaging speed. Now, what we tried to do is using very short laser pulses in attosecond time scale to generate electrons in the same time scale. Then these fast electrons acts as a shutter to see the electron motion. In very simple word, you can think about it is our atom microscope is a cutting-edge last version of your smartphone camera, which allow us to see electrons and image electrons.
So what does your image look like? What's the image that you collect?
We have our electrons coming from the microscope. We chop it like using a knife by using a laser pulse to very short electron punches. And these electron punches go through a graphene sheet, and we record a diffraction image of this graphene sheet. Then we follow by, in real time, taking different snapshots at different times, how this diffraction pattern is changing from time to time. Then we stack these diffraction images together to form a movie of showing the change of these diffraction patterns.
So what do you see as the applications of this new imaging?
Oh, actually, this is a very good question. This very fast electron microscope, which we call it atom microscope, opens the door for many applications in different fields of science. And this is what I love about it. Yes, we develop it, we physicists, but we also provide it for all the scientific community to use it for different application. Electrons carry the secrets of life, and this is how we can reveal these secrets.
What you've done, it sounds like magic. Thanks very much for
Thank
talking with us today about some very exciting research. Mohammed Hassan is pushing the envelope in quantum microscopy, allowing researchers to see aspects of atoms never before observed. You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM podcasts are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.